Hi there, this is Joe again, and we are carrying on with division. I would like to address, before we move on to anything that's looking rather new, I'd like to address a question that often comes up, and people make this mistake a whole lot of times. So I just decided I'd make this question up right now, and it's 609 divided by 3. And you'll see what's different about this question as we go through it. So let's just go through it and we'll address the problem when we get to it, okay? So how many times does 3 go into 6? Well, it goes in 2 times. The 2 goes on top of the 6. Now, that says to me already that my answer is going to be 200 something. Not 20, but it's going to be 200 and something. So let's carry on. 2 times 3 makes 6. We subtract, we get 0. So let's bring down this 0. And oh, there's a problem. How many times does 3 go into 0? Well, it doesn't. And here's the kicker. When you bring a number down, you must put a number up. So it doesn't go, so put a 0 right there. Now we'll bring down the 9. We'll go like that. We'll extend this. Okay, these numbers out in front, they don't really matter. Now, how many times does 3 go into 9? Oh, that's easy. That's 3. And 3 times 3 is 9. And we're done. Okay, so I could point out the question or two like that on your page, but I'm going to let you deal with that yourself. Find that out when you get to it. But whenever the rule we have is whenever you bring something down, you have to put something on top. Okay? And also, I got a little bit ahead of myself on the last video when we said we were going to do 2-digit division. And I want to just go back. Do you remember this factor tree, prime factors page we had before? Well, I didn't spend a whole lot of time on it because we needed to learn how to do basic division. So I'm returning to this page right now. I'm going to do 2 questions on it, and then that will be single-digit division finished, okay? So sometimes our plans change in midstream, and that's the way it goes. Okay, I would like to do a factor tree on this prime factors page, and I'm going to pick the number 36. Okay, so factor. And I'm going to take this off. And I'm going to take this off. So here we have factor trees. Let's factor 36. Okay, so we're going to go like this. I want to get 2 numbers multiplied together give me 36. Well, let's think about what we've learned so far. I see that 36 is an even number. So I know it must be divisible by 2. So you know what? Let's go find out what 36 divided by 2 is. So we'll use the lessons that we just had. So 36 divided by 2, and we get 1 up there. 1 times 2, that's a 1. I'm going rather fast here, but that's okay. You've been practicing. And then 2 goes into 16 8 times, and 8 times 2 is 16, and that's beautiful. We have no remainder. So that means I can say, oh, 36 is equal to 2 times 18. Now I want to keep breaking it down, 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 okay? The 2, there's nothing we can do with the 2. It's already a prime number. What can we do with the 18? Well, the 18 is a little bit smaller. We might be able to work with it. I'm going to call that 3 times 6. Okay, so, well, 3 is a prime number, but 6 is not. So we got to break that down. So far we have 2 prime numbers. Are we still seeing that? Now the problem is I'm working on the side, so I can't tell when I'm straight. And then 6, we all know, is 2 times 3. Okay, so there we are. We have our we pretty much have our answer. But I'm going to go and remember what I said last time. I'm going to put them all in numerical order. So I'm going to go 2 times 2 times 3 times 3. And there we have it. I know it's not very neat, but okay, so there we have it. 2 times 2 times 3 times 3. That is factoring the number 36. And I want to do one more. Let's see. Let's do the number. I'm going to make this one up. I'm going to make this one up, and it's going to be 57. And if you're thinking about it, you might think, hey, 57 is a prime number. Well, you know what? It's not. And I'm going to give you a little trick. This is where the trick comes in. I'm finally getting to the point where I get to give you a trick. So let's do 57. Let's go through our main ones that I was talking about the other day. Do you remember the day we talked about divisible by 2 or the multiplication tables? The 2 times table, the 3s, the 5s, and the 10s. Well, this is certainly not divisible by 2, is it? Because it's an odd number. It's not divisible by 5 because it doesn't end in a 5 or a 0. And it's not divisible by 10 because it doesn't end in a 0. So we have one left that I'm going to get you to try, and that's 3. Do you think 3 goes into 57? Well, it does, and I'm going to just prove it to you over here. Let's go. We'll do it the old-fashioned way. And so 3 into 5 goes 1 time. 1 times 3 is 3. That's a 2. Bring that down. That's a 7. 3 into 27. Oh, wow. That's a 9. 9 times 3 is 27. Look at that. What does this tell me? It says that 3 times 19 is equal to 57. Well, how about that? So that's a 3 times 19. And 19, that's it. It's a prime number. You might have thought 51 was a prime number, but it's not. Okay, so here's our answer right there. We're done. So watch this trick of threes. I really like this. I can tell that a number is divisible by 3 if I take its digits and add them up and find that they're divisible by 3. Okay, that sounded like a mumbling idiot, but anyway, I'll try again. We have the number 87. Is 87 divisible by 3? Well, this is how you can find out. Let me just write the question. Is 87 divisible by 3? In other words, could you take your calculator, plunk in 87, divide by 3, and get an even, just a number with no decimals? Yes, you can. And this is how the trick goes. You break the 87 down, or whatever number you're interested in. In this case, it's 87. And you take the 2 digits, and then you add them up. And then you add them up and you look at that answer and then you say to yourself, is that answer divisible by 3? So watch. So 8 plus 7 equals 15. The question now becomes, is 15 divisible by 3? And since 15 we know is divisible by 3 because we can count by 3s and get to 15, because we know this is divisible by 3 and it is even evident on the most basic times table sheet, then the original number must have been divisible by 3. So since, I'll put a period, since 15 is divisible by 3, so is 87. With a lot of excitement, there we have it. So is 87. And what are we at for time here? I'll give you a real crazy one, okay? Let's do one more. Is 702 divisible by 3? Well, what do? We add the digits together. Add 7 plus 0 plus 2 equals 9. Okay, is 9 divisible by 3? Yes. Therefore, 702 also is. Since 9 is divisible by 3, so is 702. Why does that work? I have no idea why it works. All I know is that it does work. Okay, so this page with the factor trees, there's 4 pages there. They all use either 2s, 3s, 5s, or 10s to get started. Okay, so that'll be on your first test. And if you want to just take your calculator for a second, go 702 and then divide by 3, you'll get a number. And let's see, what is that number going to be? For some reason, I'm feeling a little lazy now. I'm not, that's not good. 702 divided by 3 is exactly 234. Okay, so that's the lesson for this time round, and by now you should be able to do anything, any division by 1 digit, and any of the factor tree problems. All right, take care, have a great day.